All types of industrial equipment require safety devices and emergency shutoffs in order to provide safe and reliable performance. Design improvements that increase the safety afforded by such equipment give the end user the benefit of a lower chance of injury, increased uptime, and a more efficient workplace. Manufacturers are always striving to improve the safety and performance of their products. Chemical heating is no exception.
My name is Derek Sanislow. I've been a mechanical engineer at Process Technology for 13 years and currently work in research and development. Electric immersion heaters are used in chemical cleaning, pre-treating, and processing lines to maintain tank temperature. Typical immersion heaters use resistance wire as their source of heat, which may operate around 900 degrees Celsius under normal conditions. If these heaters were exposed to air, the surface temperature would rapidly climb to those same temperatures, endangering surrounding materials and creating a fire hazard. That is why these type of electric heaters require over-temperature and low liquid level shutoffs, along with other safety devices. The integration of these safety devices is the responsibility of the technician performing the equipment installation. If electric immersion heaters are not properly installed with the required safety devices, or such devices are removed or bypassed, and a low liquid level event occurred, there is a risk that the heaters can remain energized and could pose a serious fire hazard, threatening personnel, property, and environment. The safety lies in the use of PTC thermistors instead of resistance wire as the source of heat. These chips produce a variable resistance based upon temperature. This means the hotter the chips get, the lower the heat output. This is an illustration of the safety provided by Smart One electric heaters. In this graph, the red line shows the surface temperature of the heater and the blue line shows the heat output. This heater was operating in a water bath at 100 degrees Celsius. At time index 0, the heater was removed from the water so we can observe its response. You can see that the surface temperature immediately starts to rise and after a few minutes reaches a steady state around 270 degrees Celsius. At the same time, you can see that the heat output of this heater dropped from just under 3,000 watts to around 330 watts. So when exposed to air, this Smart One heater reduces its heat output to 13% of its normal output rating. This graph compares the maximum surface temperature of a Smart One electric heater with the ignition temperatures of various plastics and other materials typically found in a chemical processing line. As you can see, the maximum surface temperature of the Smart One heater is below the ignition temperatures of these materials. It is not possible for this heater to ignite these materials due to a low liquid level event. Furthermore, since safety is built in, there are no temperature protectors to replace or reset. Here is a Smart One heater prepared to demonstrate the built-in safety provided by these products. This immersion heater is set up to operate in a fume hood outside of any liquid. For a typical electric heater that uses resistance wire for a source of heat, this would pose an immediate overheat and fire hazard. We will energize this heater and place samples of polypropylene and CPVC directly to the surface of this heater to observe the results. The heater then gets switched on. The display is measuring the surface temperature of the heater. Once the heater is energized, you can see that the surface temperature immediately starts to climb. After 90 minutes of operation, the surface temperature of the heater has stabilized around 230 degrees Celsius. There are only slight signs of high temperature damage to the plastic samples. After 90 minutes, the plastic samples are removed. The polypropylene sample is obviously melted where it was in direct contact to the heater surface. The CPVC sample exhibits some black carbonizing where it was in direct contact with the heater surface. After 90 minutes of direct contact with an energized electric immersion heater, these two plastic samples only suffered some melting or blackening where they were in direct contact with the heater surface. This is a substantial increase in the degree of safety provided by electric heaters.
Our Smart One heater line offers over-the-side, L-shaped, and screw plug heaters in titanium, 316, and 304 stainless steel. These are available in wattages up to 18 kilowatts. The Smart One heater is capable of operating in air, sludge, or scale, making it longer lasting and safer than resistive heaters. The Smart One heater is CUL, US, and CE certified. It adds a layer of security in protecting personnel, property, and the environment. Be safer. Choose Smart One.